A cosine function is shown in the standard coordinate plane below. One of the following equations represents this function. Which one? So we need to find which of these cosine equations models this graph. So the first thing we can look at is the amplitude. So the amplitude is the distance from is the height of the graph essentially from the distance from its midline here. So we see that the amplitude of this graph is 3. So that means we need to have a constant amplitude of 3. And we see here in the answer choices that there are some graphs that have an amplitude of 2. We can rule those out. And we can check to see that the amplitude is 2 because at an x value of 0, if we plug this into our cosine equations, we should be left with a value of 3. So when x is equal to 0, the argument in all of these cosine functions is 0, and the cosine of 0 is just 1. So multiplying it with 3 will give us 3. So in these three equations, we have an amplitude of 3. While in these two, if we have cosine of 0, we'll just be multiplying 1 with 2, which will give us an amplitude of 2, and that's incorrect. Now, if we look at this graph again, we can see that one complete wavelength only takes has a smaller period than the normal cosine graph, because we can complete one wavelength going from a y value of 3 back to a y value of 3 only took pi from 0 to pi on the x-axis. So that means the period of this graph has been decreased. Now, in a cosine equation, when we have the amplitude times cosine, and then we have some period number times x, when this period is a number greater than 1, we are decreasing the period of the graph, meaning the graph would get expanded. It would be pushed farther apart. Or sorry, when we decrease the period, the graph would be smushed together. The gaps between the lines would become smaller, and the wavelengths would be much faster, or much smaller, and the frequency of the graph would be larger. When the period is less than 1, when we have like a fraction, that will be increasing the period, and the graph would get pulled apart. The graph would look something more like this, whereas a smaller period, the graph would be much faster in producing more wavelengths. So we see here in this graph that the period is only pi radians, whereas in a cosine function that only has a constant 1 being multiplied with x, the period is actually 2 pi. So we need to multiply the period with a number greater than 1. In this case, h and j are being multiplied by numbers less than 1, 1/3 and 1/2. But in k, we're multiplying by 2. This would this would half the period, and from the normal period to pi, which matches the graph we have. We see that we could go from 3 back to 3, the y value of 3, in only going from 0 to pi. So the period was smaller. So we can rule out h and j, and that means k is the correct answer.